So I'm going to show off a potential solution, or one way of doing a means of allowing people to request infrastructure that is configured via Terraform without needing to know how Terraform is doing that, or even necessarily the fact that Terraform is involved. So Terraform, many people think of it as this tool that is just used to spin up virtual infrastructure in public clouds, and to be sure, it does do that, and does it pretty well. But you can configure anything you like that has an API, including Terraform Cloud and Enterprise itself. So you can write Terraform code that configures more Terraform workspaces, which, if you're an expert Terraform user, works okay, but bumps up the learning curve. And so, rather than having people who need to create their infrastructure with Terraform come into Terraform Cloud, create their workspace, set up variables, write their code, you can have Terraform configure workspaces in Terraform Cloud. But you need a way of abstracting away the fact that Terraform is in there, because otherwise, even people who know how Terraform works, the learning curve is, it's quite high. And so what I've got here as a potential solution for this is defining Terraform workspaces as YAML files. The example I've got here, this is an example YAML file in this README here. This says I want to spin up a web server, and that maps to a specific set of Terraform code for my workspace. So that bit defines what Terraform code or what Terraform modules I want to be using. And then the rest of these are just parameters for that Terraform code. So in this case, spin it up in London, have an image of this height, give me a picture of a cat. And then name is just the name of the workspace. And so the way this works is within our Terraform code, there is a section right here. It's a very short bit of code that says, look for all YAML files in this workspaces directory, convert that to a set, and then for each file in that set, decode the YAML. And so now we have this web server workspaces variable that is a set of decoded YAML files. We take it a little step further than that. So this is, you can think of it as just a list. We can convert it to a map. So what ends up happening here is we have a map where you take the name of the workspace, and then that maps onto the content of that YAML file. So now what we have in this web server workspaces map is something that we can use Terraforms for each iterator on. So for each one of these, we can, in this case, run this module which creates Terraform workspaces, but it can create anything you like. It can even create your infrastructure directly if you prefer. So it takes, for each of these files, so in this case, workspace name, and then everything else in here, down here, these are the values from that YAML file. So having something like this, it means a developer could potentially come into this repository, create a new YAML file like this, in this format, either directly or via a pull request, and then Terraform would then spin that up. So I'm going to show you doing that directly. So I'm just going to create a new file in the workspaces directory. Workspace is cat.yaml. We'll just call it cat. Web server, London. I'm going to commit it directly. And so this gets committed there. And then what we see here is we have Terraform is running a plan. If I check the latest plan here, so it has now found that file and it wants to use that to create a bunch of Terraform resources. So in this case, all of these resources are abstracted away as part of this module. But what it's creating is a new workspace, setting some variables on that workspace, and then it's kicking off a plan and apply on that workspace, which will then create that infrastructure. So if I have a look at this workspace now, it is configured. If I look at the version control, it is configured with that repository. It's in this directory of that repository. It's on that branch. It's got all of these variables, and these are pushed directly from the seed workspace. And then it kicks off a run. So our seed workspace is now waiting on this workspace to run. So it's doing its plan. So it's figured out that it needs to create a bunch of resources, in this case in AWS. And now it's applying that. And there we go. It has now finished creating these things. And because this is finished, the seed workspace is now finished. If we take a look at the outputs of this workspace, I've got this configured to give us the IP address to our web server, which we see gives us a picture of a cat as requested. So that's great. That's a way of spinning up Terraform workspaces as code without needing to explicitly write some Terraform code to do it. All you need to do is create one of these YAML files. And for technical users who don't necessarily know much Terraform or care that Terraform is involved, creating a file like this in this repository could work. For your non-technical users, though, you will need something a little more than that. So you can't necessarily expect a non-technical user to be able to raise a pull request in your version control system of choice. So what you need is some means of your non-technical users filling in a form with all the parameters that they care about for the infrastructure they're requesting. And then that abstraction is responsible then for creating this file in your version control. As an example of what that could look like, I have a GitHub Action set up. So I run my GitHub Action. It asks me for a name to identify my web server. Where do I want to launch it? I'll say Ireland. How big of an image do I want? I'll say very short but wide image, and I want a picture of a dog in this case. And the fact that this is a GitHub Action is not important, because you can do this sort of thing with various different tools. GitLab Pipelines allows you to do something like this, and there are various other tools that you can use to template out files into Git repositories. But if I click run, give it a couple of seconds and that should start running. And we see that it was successful. And what this did is it has created a file in the repository, and it has raised a pull request for me. Now you could have this form or whatever tool you're using commit to the repository directly. I've done this where it creates a pull request just because then you can have someone review it and approve it. So yeah, we want some infrastructure, we want a web server, call our workspace doggo, and then there's all the parameters for it. With a pull request, you could then add in whatever approval process you need. So you can have, in this particular case, I can just merge this, but with your pull requests, you can set it up so that it can only be merged after people from certain groups have approved it, and so on. That's the sort of problem that has been solved in many different ways in many different version control systems. But in this case, yeah, we say that it's all good, we merge it. And then again, we see our seed workspace is kicked off, and that plans, and that will result in another workspace being created and infrastructure being provisioned. Cool, so there we go. We can now see that our Doggo workspace now exists. If we go into that one, same as before, we've got a link to the web server itself. Click on that, picture of a dog, as we requested. And this is just a simple toy example with this web server, but hopefully you can see that this could be extended to more complicated resources that are managed with Terraform. There are a couple of caveats that I have at the moment with how this way of doing things works. For a start, there is a bug in the multi-space provider that I'm using, which is a relatively new Terraform provider written by Mitchell Hashimoto himself. And the bug that's going on here is when my seed workspace triggers one of my child workspaces, if I have cost estimation enabled or any Sentinel policies in my Terraform cloud organization, the provider doesn't yet know how to handle that. So this provider is very much early days at the moment. It is written with the assumption that it's going to be used against a free tier Terraform Cloud, where policy checks and cost estimation don't exist yet. But it shouldn't be tricky to fix. And so if you are going to be using this pattern of creating Terraform workspaces with Terraform code, whether you do this abstraction with YAML files or not, then really this bug needs to be fixed before it's suitable for production production organizations with cost estimation and policies. The other caveat that I have with this is how we are passing variables from our seed workspace into our child workspaces. So right now, our seed workspace has some variables associated with it. It has a Terraform token that it uses to interact with the Terraform API. And just setting that as an environment variable is sufficient for the Terraform. It's sufficient for Terraform provider to create resources in Terraform Cloud, and for the multi-space provider to trigger those workspaces. That's all fine. The caveat that I have here, and the way that I would want to improve this in future, is the way it's handling these AWS credentials. So this is spinning up web servers in AWS, and so it needs AWS credentials to do that. In this example, I am just defining these variables on the workspace itself. As you can see here, there is now a new feature in Terraform Cloud called variable sets. We announced this very recently. It's still in beta. And what you can do with this is, rather than defining these variables on the workspace itself, you define these variables globally in your Terraform organization, and then these variable sets are applied to your different workspaces. And so that way you don't have to define these variables in each workspace. And the way my Terraform code for this seed job works is it takes these environment variables that are defined in this seed job and then copies them to the variables on the child workspace. And what that means is that these variables now exist within the Terraform state of my seed workspace. And environment variables like this wouldn't normally persist in your Terraform state. But because the seed workspace needs to read them in order to push them to this child workspace, they do end up in the Terraform state. And so the workaround, so this is currently a workaround. In future, a better way of doing this is to make use of these variable sets. And so you define your AWS credentials in a variable set, and then rather than pushing these variables from one workspace to another, you just apply that variable set to our child namespace, child workspace. The only reason I haven't got that set up at the moment is this is a beta feature. It's still a work in progress, and as such, the Terraform Cloud and Enterprise provider doesn't yet support these. So yes, that is an overview of this Terraform Cloud seed config pattern that I've come up with as a means of allowing people to request new Terraform workspaces to spin up infrastructure without needing to know how the underlying Terraform works. Hopefully some people will find this useful. There are various cases where there are many use cases for this sort of thing, and feel free, this repository is public, feel free to fork it, make any pull requests you like, etc. It's a work in progress, but hopefully people can find this useful.